Okay, we're going to talk about now the other way of representing functions and relations, that is with equations. We're going to talk about what the difference between explicit and implicit is. Then we're going to talk about what's called function notation. Now, first off, let's define explicit and implicit equations. An explicit equation is an equation solved for a specific variable. So you have a variable by itself. An example, y equals 2x plus 3. Okay, y is by itself. On the other side, you have your x. So this thing is defined, you'll hear it say it's defined in terms of x. Y is in terms of x. You could also have radical equations like y equals the square root of 3x minus 4. You could have y equals x squared plus 5x plus 6. You could have quadratic. All of these are solved explicitly for y. Now you have implicit, which would be the opposite of that, and that would be an equation not solved for a variable. Now, when you get to calculus, you do implicit differentiation and all that, and you'll know what implicit means. That'd be like x squared plus y squared equals 16, which is actually the equation of a circle, if you remember. You could have 3x plus 6y equals 10. That would be standard form of a linear equation. Both of those are implicit equations. Okay, next example says write each equation explicitly in terms of x. That means solve for the other one. Leave the x stuff with all the multiplication and addition. Leave all the numbers over there with the x and solve for the other one. Then indicate whether the equation is a function. So here we go. We're going to solve explicitly or write the equation explicitly in terms of x. So it means we're going to solve for the y, get the y by itself. So let's move our x over first. And we've done these before. The 1x moves over to the other side by doing minus 1x. We're going to divide everything by -4. And what you've actually done is you put this thing in slope-intercept form. So you've done that before. And the next question is it a function? And according to the vertical line test, since this is a line, there's no points above points. So yes, we know that for sure this would be a function. Number 2, x squared plus y squared equals 25. We've got to try to somehow get y by itself, which is again called putting it in terms of x or according to x. So let's move our x squared over. So you have y squared equals 1x squared becomes -1x squared. Leave the 25. Or you could also flip-flop those around. It might look a little bit better. To get rid of a square, we have to do plus and minus the square root of -x squared plus 25. Now, if you were to graph this, and hopefully we already remember, x squared plus y squared equals r squared is the equation of a circle. And if it's a circle, there is absolutely no way that it can be a function. Now, let's talk about another reason it's not a function. If you were to take an x value and plug it into this, something like 3, look what would happen. You would have -x squared. That'd be -9 plus 25, which is 16. When you take plus and minus the square root of 16, notice what you get. You get a +4 and you get a -4. When you plug in 3, you get 2 different values. So that's another way to check to see if something's a function. If you plug in an x value, would you get 2 different y values? And this plus and minus right here tells you for sure, yeah, you're getting 2 different answers when you plug in that x. Next one, again, getting y by itself, we now have y plus 1 squared. Well, we can move that x over really easy. Let's go ahead and do plus x. Then to get rid of that square, we're going to plus and minus square root. So that's going to be plus and minus the square root. I don't like 3 plus x. I'm going to write that as x plus 3 instead. And then we're going to move the 1 over by subtracting 1. That'd be -1 plus and minus the square root of x plus 3. Now this one's very similar to the last one. Is it a function? Let's see if we can figure out if it's a function without even plugging in, without even graphing it. Let's plug something into this. Let's plug in something that's going to make it pretty easy. Let's plug in I know the square root of 9, so let's plug in a 6, and let's see what happens. If you plug in a 6 here, you get the square root of 6 plus 3, that's the square root of 9. You get -1 plus and minus the square root of 9. So when I plug in 6, I get -1 plus 3, and I get -1 minus 3. I get 2 and -4. I get two different y values. The reason for that is this, if you were to graph it, is actually a sideways parabola, which definitely does not pass the vertical line test, so this would not be a function. Next up, getting y by itself. Let's move our term over. So you have, actually let's do it different because I have a negative in front of this y stuff, so let's move it over to make it positive and move the 7 over here. So now you have 1/2 x, the 7 becomes a -7, is equal to the positive cube root of y. Then to get rid of a cube root, we can come over to this other side, and to get rid of a third root is just like getting rid of a square root. We're going to raise the other side to the third power. So now you have y by itself, and you can try to plug in any value you want to. Plug in 8, half of 8 is 4, 4 minus 7 is -3. When you raise to the third power, you get a single answer. Okay, so since the plus and minus throws us off, this one has no plus and minus. You get, for every x, you get a single y. If you were to graph it, it looks something like this. And yes, this would be a function. Number 5, same thing. I don't like this minus y stuff, so let's move it over and move the 8 over. So you now have x minus 8 equals a positive square root of y plus 1. To get rid of a square root, we're going to come over here and we're going to square. We're going to do the opposite. So you get x minus 8 squared equals y plus 1. To get y by itself, now we just have to move the 1 over. So you have x minus 8 squared minus 1 is equal to y. So the question is, would a single x value ever yield two different y values? And you can try some out. If I were to plug in a 4, you get 4 minus 8 is -4. When you square it, gives you 16 minus 1, which gives you a single y value. But is there any way that I could get ever two different y values? When you plug in 8, 8 minus 8 is 0. When you square it is 0. When you subtract 1, you get -1. This side actually honestly looks like an order of operations problem. There's no plus or minuses or anything that would force you to get two different answers. So therefore, without even graphing it, yes, this is going to be a function. And number 6, to get y by itself, again, we're going to have to use our trick here. The trick is, if you have two different sets of y's, keep them together and move the -1 to the other side. So you have xy minus 5y equals 2x plus 1. Now, how do you go from having two different y's to just one y? You factor. So let's factor out a y, and you're left with an x and a -5. And that's equal to 2x plus 1. Since y is being multiplied here, to move it over to the other side, you're going to mark it out and divide by x minus 5. So you have y equals 2x plus 1 over x minus 5. And again, the question is, will I ever get two different y values when I plug something in? Well, think about this. 2x plus 1 over x minus 5. Let's go back to our early days of algebra. And if I say take this expression and plug in x equals 6, you didn't have two different answers. You had 13 over 1, which was 1. Or 13, excuse me. 13 over 1, which is 13. There's not going to be two different answers here. So yes, this will be a function. If you're able to put in an x value and only get one y value out, because again, a function is when each x is paired with only one y. Okay, now, explicit functions are frequently written in what's called function notation. Here's an example. I know that y equals 2x plus 3 is a function because it's a line. If something is a function, instead of writing something as y equals, we can write it as f of x equals that same thing. Y and f of x is the same thing. Now, f of x does not mean f times x. This is read as f of x and interpreted as the value of the function f at x. Okay, so let's explain that a little bit more with some examples. So here where I say f of x equals x squared minus 6x plus 23, that's the same thing as y equals x squared minus 6x plus 23. So what does this f of -5 mean? That means take your function, and this is the whole purpose of function notation. It means take your function, and where you have an x, put this. To find f of -5 simply means the x value is -5. Just plug in -5. So you now have -5 squared minus 6 times -5 plus 23. Everywhere you have an x, just plug in -5. And that tells you what f of -5 is. -5 squared is 25. -6 times -5 is a positive 30 plus 23. So therefore, f of -5 is equal to, that'd be 55 plus 23, which is 78. Another purpose of function notation is I can now see right here exactly what I plugged in and exactly what I got when I plugged it in. I can see my input and I can see my output. I can see my x and I can see my y all right there in the answer. Number 8 says find h of 9, which means take your function and in the place of x, put a 9. So we're going to do 7 minus 9 to the second power, which is 7 minus 9 times 9 is 81, which is a negative 74. Input 9, output negative 74. That would be a point on your graph. Okay, let's move on to number 9. You're asked to find p of 4. So to find p of 4, it means take out every x that you have and put a 4 in its place. So on top you have 4 plus 1. On bottom you have 2 times 4 squared plus 4 times 4 minus 13. On top you have 4 plus 1. Now anytime you're dealing with fractions, remember that these are implied parentheses. You have to do everything on top together and everything on bottom together. 2 times 4 squared, make sure you square before you multiply. That'd be 2 times 16, which is 32, plus 4 times 4, which is 16, minus 13. So on top you had a 5. On bottom you have 48 minus 13, which is 35. Since 5 is not divisible by 35, you're going to treat it like a fraction and simply reduce it. That would equal 1/7. Okay, number 10, g of x, and we're asked to find g of -2. So we're plugging in -2's, and if you would like to, here's you another trick. As you plug them in, if you want to go ahead and do your exponents, because parentheses exponents are going to be your first couple of steps, you can. -2 to the third I know is -8. Plus 3 times -2 to the second would be a negative times negative is a positive. Plus 7 times -2, I'll multiply in the next step. And you can save yourself a step. That'd be -8 plus 12. A positive times negative would be a -14 minus 4. That would be, now I like to do this. I like to go ahead and put all my negatives together and put all my positives together. My negatives would be -26. And then you have 12 minus 26, which is a -14. So input, when I put in -2, I get a -14. Again, you could write that as a point as well. Okay, number 11 says to find q of -15. So q of -15 would equal the square root of 6. Now we got to do -2 times -15. I'm going to go ahead and do that. As I write it down, that would be a positive 30. So therefore, q of -15 would be the square root of the parentheses, and under that radical symbol implied, that's the square root of 36, which is simply 6. Number 12, p of -10. We've got to do the absolute value. We're going to multiply half times -10, which is the same thing as half of -10, which is -5 minus 14. Implied parentheses inside those bars, that's -19. The absolute value of -19 is a positive 19, and that's it. Okay, number 13, it says to find f of 4. F of 4 would equal 5 times -3 raised to the 4th power. Make sure you do exponents before you multiply. -3 to the 4th would be a positive 81. 5 times 81 is 405. Number 14, a of 17 means to plug in 17 for your x value. That'd be the negative of the cube root of, we can go ahead and multiply that, it'd be 34 minus 7, which is the negative cube root of 27. That's a minus there. When you're doing, okay, where does these fall in order of operations? Please excuse my dear Aunt Sally. A radical is actually also an exponent. So this is going to fall in our second step. you have to do the radical before you take the negative. So the negative stays, and the cube root of 27 is 3. So your answer, -3. Input, output. Number 15. Now we're evaluating these functions for expressions. We're not plugging in a number, we're plugging in an expression. So to find f of 3y squared, do it the same way. You're going to take out this x, and you're going to take out this x. And in the place of the x's, you're going to put this, 3y squared and 3y squared. Clean it up using your the stuff that we've been going over. Raise both of these to the third power. We don't have to FOIL or distribute or any of that because there's no plus or minuses. 3 to the third is 27. To raise a power to a power, again, we multiply the powers. That's 27y to the sixth. Plus, raise both of these to the second power. 3 to the second is 9. Y squared squared is y to the fourth, and there's no like terms there. That's it. G of x, we've got to take out the x and put in a -5c. So we're going to take 3x minus 10 over x plus 5, and everywhere we have an x, we're putting -5c. And that is how we find g of -5c. Multiply, this is not distributive because there's no plus or minuses. That's -15c minus 10 on top. -5c plus 5 on bottom. Now we might be able to clean that up a little bit. I think the top of -5 could factor out of the top. You'd be left with a positive 3c plus 2. On bottom, you can factor out a -5, and you're left with a c minus 1. -5 and -5 cancels, and your final answer is 3c plus 2 over c minus 1. And just a reminder with that problem, we talked about rational expressions in the first chapter. Reminder that you can't cancel out this c with this c. If you're going to cancel out this c, you would have to cancel out the whole term. Okay. Now, why could we cancel out the -5s? Because there was no plus or minuses. There was nothing attached to those -5s. Number 17, h of 2a plus 7 means take out the x's and plug in 2a plus 7. So you have x squared minus x minus 1. In the place of your x's, we're putting 2a plus 7s. So to square 2a plus 7, I'm not going to write it down, but you will FOIL this out. That'd be 2a plus 7 times 2a plus 7, which would be 4a squared, plus 14a plus 14a would be plus 28a plus 49. A minus in front of parentheses, you do have to distribute and change signs. That'd be a minus 2a and a minus 7. Bring down your minus 1. Now it's just combining like terms. Would be 4a squareds. 28 minus 2 would be plus 26a. And 49 minus 7 minus 1 will be 42 minus 1, which is 41. And I don't think that will factor. Okay, the last one of these, k of x, we're asked to find k of m minus 1. So all we're doing is taking out all of our x's in our function, which was 4x to the third plus 7, and we're plugging in m minus 1. So we have to raise m minus 1 to the third power, which is not going to be fun. Let's come over here to the side and let's do m minus 1 times m minus 1 times m minus 1. That's going to take a little while. Multiply these two together, and I get m squared minus 1m minus 1m would be minus 2m plus 1 times m minus 1. Now we have to distribute the m squared minus 2m plus 1 to m minus 1. M squared times m would be m to the third. M squared times -1 is -m squared. Now distribute -2m gives you -2m squared plus 2m. Now distribute the 1, that would give you plus m minus 1. Combine all your like terms would be m to the third. Done with that. Now let's combine our m squared to be -3m to the second. Done with those. 2 plus 1 would be plus 3m minus 1. So now I have 4 times that stuff, m to the third minus 3m to the second plus 3m minus 1 plus 7, which is 4m to the third minus 12m to the second plus 12m. Then that would be minus 4. I'm going to go ahead and combine the minus 4 and the plus 7. That would give you a plus 3, so we don't have to write all that again. Okay, the next part says use the graph to the left to solve or find each value of the function. Now, this is just teaching you how to read a graph. So f of 1, let's remind you what that means. That means your input is 1. That's your x value. The x values are on the horizontal axis. So let's find 1. So 1 on my x-axis is right here. So that means if I plug in 1, what would I get on my function? So if I plug 1 in for x, what would my y value be? And you see the y value right here. So the point here is located at 1, -9. So if I plug in 1, I would get -9. Number 20 says, what if I plug in -2? Let's go back to my graph. And now let's plug in -2, which is located on my x-axis right here. And actually, the y value when I plug in -2, notice is right there on the x-axis. So this point on my graph, when I plug in -2, is located at -2, 0. So plugging in -2 would yield 0 for y. What happens if I plug in 5? Go back to your graph. And you see, I believe the same thing happening. 1, 2, 3, 4. Here's my point located at an x value of 5. So it also gives a y value of 0. My last one, what happens if I plug in 0 for x? Go back to your graph. Here's where x equals 0 is located. This is the dot associated with x equals 0. This dot is located at 0, 1, 2, 3, 4, 5, 6, 7, 8. So when I plug 0 in for x, I would get -8 for my y value.